Alright folks, welcome back. This is Daniel for Rock the JVM, and in this video we're going to do part 2 of pure functional programming and databases in Scala with the Doobie library. Now, I heavily recommend you watch the first part where we introduced Doobie as a tool and where we set up our initial project with a Docker container. So go ahead and watch the first part first before diving into this video. Of course, as before, this particular video is for the very comfortable Scala user, and we're going to use quite a bunch of concepts that I talk about elsewhere, including the YouTube channel and my Cat's Effect course, which I heavily recommend you check out. As always, I recommend that you code with me in this video, and whenever you need to refresh your memory or just refer a teammate to use Doobie for your work project, just refer them to this video or to the written form at the blog with the link in the description. Alright, without further ado, I'm going to go back to where we left off in the previous video. So in the previous video, we introduced Doobie into our little day-to-day. We created a new project where I set up a Docker container with Docker Compose YML and a MyIMDb fictitious movie database with SQL. Now, I have my Docker container already started, so if you don't have that started already, go to this Docker directory and run docker-compose up to spin up your Postgres container if you're following along from the previous video. Now, in the previous video, we introduced Doobie and the kind of operations that it supports, including retrieving uniques or lists and updates in a variety of APIs and techniques. Now, in this video, we're going to dive a little deeper into Doobie, and I'm going to show you the kind of complex operations that you can perform with the Doobie library and with type classes. So we're going to touch upon the tagless final approach in our attempt to make our code more generalizable and more extensible. Now, the first thing that I'm going to show you are some type classes that Doobie can use to be able to translate the data that it receives from the database to your own classes or case classes, depending on how you model your data. So let's assume that in this case, I'm going to create a case class. I'm going to call this actor name, which wraps a symbol value as a string. Now, Doobie automatically is able to convert to and from case classes when you write your SQL queries in the style that we showed in the previous video. But just for the sake of argument, let's assume that you have a plain class with a val field that has a bunch of logic or some custom data type that for some reason you cannot make a case class. And you want to make your new type be supported by Doobie. Now, when we want to query, for instance, all the actor names in our database, and we want to convert them to our little class, we would write something like this. I'm going to write, let's call this find all actor names. And this is going to be an IO of actor name or list of actor name. So list actor name. And I'm going to return SQL quote. So we showed earlier in the previous video how we can use the custom SQL interpolators from Doobie. And I'm going to say select name from actors. So this is the normal database query. Now I'm going to call .query method on it. So I'm going to say query with the type actor name. And then I'm going to say to list to convert that query to a list. And then I'm going to say transact with the transaction manager that we built at the beginning of the application. If you remember the beginning of the previous video, the first thing we did, we created a transactor, which is able to fetch things from the database by creating new connections every time. So find all actor names, let's say custom class, so that we don't conflict with the first query of the previous video. Now, normally this would not work because actor name is a standard class and Doobie would not know how to convert strings to classes that wrap strings. Now, if you want to be able to do that, you would need to create an object. I'm going to call actor name because we want to write this in the companion object. And I'm going to define two implicit instances. Now, these implicit instances will be used by Doobie to be able to convert to and from between strings and actor names. So I'm going to define an implicit val I'm going to call this actor name get, which is of type get actor name. And get is a type class that is able to translate a string into an actor name. So I'm going to say get of type string, which obviously is supported by Doobie. And the get string, which is a type class that is able to read strings, I'm going to map every string to an actor name. So I'm going to say string arrow actor name or new actor name of that string. So every string that Doobie can read from the database, I'm going to convert to an actor name. And similarly, I want to be able to write an actor name into a database. So I'm going to define another implicit val. I'm going to say actor name put, which is of type put, that I'm going to have to import. So put from Doobie with type actor name. And this is a type class that is able to write an actor name into the database, of course, into the types that the database can understand. So I'm going to have put of type string. Now, technically, get and put are functors. Get is a covariant functor and put is a contravariant functor. I talk about these concepts in the CATS course. And I'm going to run a method called Contra Map that is able to transform an actor name into a string, which the database can then understand. So I'm going to have actor name arrow actor name dot value. So I'm going to turn that back into a string. Cool. So with these implicit values defined in the companion object of actor name, I will then be able to run this query, find all actor names with my custom class. So I'm going to copy this and I'm going to paste it in my run method, which is the main application. So find all actor names custom class .debug. If you remember from the previous video, at the beginning of the video, we defined this extension method, which is able to print the value of an effect before returning that effect for further processing. So at this point in my database, at the end of the last video, we have a bunch of real actor names and a bunch of fake actor names that I added as demonstrations. So I'm going to run this application and we should be seeing all the names returned in a single list. Now, this list contains actor names which are being printed quite weirdly here because actor name doesn't have toString. So I'm going to define toString and I'm going to say value so that we don't have any other weird printing here. Okay, so we have list of, and we have all the names in the database. So this is how you can create your own custom support for your own custom classes with Doobie by creating this implicit values that Doobie will then use to convert to and from the data types that the database can understand. At the same time, there are some other type classes that are called read and write that serve a very similar purpose. And they're useful for when your classes or case classes that you want to support have multiple fields because get and put only support a single value being read. So for instance, I'm going to create a case class. I'm going to call this director ID, which wraps an ID of type int, another case class with director name with name as a string, another case class, director last name, which contains the last name as a string. Now, I structured these as so-called value types, which you can find more explanations in the dedicated value types video here on the channel and on the blog as well. And I also added in the project in build.sbt a link to the new type library, which is able to annotate your value types, case classes with a single argument, with a new type annotation, which allows the compiler to automatically deconstruct these case classes into their primitive types. But these are very useful for us for data modeling in our little code. All right, so that's pretty useful. If you want to use the new type library, you already have the definition there. And also the blog version guides you to that. But this will prolong my compilation time, which I don't want. Okay, so enough with that intro. we have director ID, director name, and director last name. And I'm going to define a case class. I'm going to call this director, of course, which will have an ID, which is of type director ID. We have a name, which is of type director name, and last name, which is director last name. Cool. Now, if you want this director case class to be supported by Doobie automatically, where the fields are themselves case classes, you will have to write your own read and write type class instances for your custom class that you want to support. So I'm going to write an object called director, and I'm going to define an implicit val. I'm going to call this director read, which is of type read. I'm going to import read from Doobie, so Doobie util. Read of type director. Read is very similar to get, only that read also supports tuples or multiple values being read. So I'm going to use read of type tuple int string string. And read is very similar to get, so we are going to map every tuple that Doobie can read from the database into a director. So I'm going to have a map, and I'm going to deconstruct that tuple automatically. I'm going to have case with ID, name, and last name. And I'm going to return a director with director ID with ID, director name with name, and director last name with last name. All right, and very similarly, I'm going to define an implicit val director write, which is of type, not surprisingly, write of type director. And this will be a write of a tuple, so write of tuple int string and string. And similarly to put, I'm going to use the Contra Map. So I'm going to have Contra Map, and I'm going to take a director, and I'm going to deconstruct that. So I'm going to have director with, I'm actually going to use director ID with ID. I'm actually going to take this structure over here because I don't want to type it again. And then I'm going to return the tuple ID, name, and last name. Okay, so if you want to write a director to the database, you'll have to deconstruct that, and you'll return a tuple, which Doobie is able to write to the database. Now, with these implicit vals in place, that is in the companion object of director, you can now read and write directors to and from the database automatically. So this was the first thing that I wanted to show you in this video, which was how to make your own case classes be supported by Doobie through the implementation of type class instances, get, put, read, and write. The next big thing that I want to show you was how to write large queries in a variety of ways. So you learned from the previous video that you can write a SQL interpolated string, and this thing can be as big as you want. So for instance, if we want to find all the movies by name, we are going to have quite a hard time because movies have an ID, a title, a year of production, a list of actors, and a director. Now, actors are in a different table, directors are in a different table. So if we want to find all the movies by title, we will have to do a three-way join between the movies database, which contains a string, title, year, and we are going to have a mapping between actors and movies, and then a mapping between directors and movies. So we're going to have quite a complex query to run. So I'm going to write a method, let's say find movie by title as a string, and this is going to return an IO of, let's say, option movie, because that particular movie with the title that I'm looking for might not exist in the database. So I'm going to run my little query as SQL quote, and I'm going to use triple quotes here because we are going to write quite some code. So I'm going to have select, and I'm going to say m.id, m will be the movie's table, so m.id, m.title, and the column is called year of production, and then a bunch of other columns including the actors and the director, but I'm going to have from, so from movies M, and then I'm going to say join, and we're going to have movies underscore actors, the mapping between every actor and every movie. So I'm going to say movies actors, I'm going to call this table MA on, and we're going to have m.id equals ma.movie underscore id. You can check the diagram of tables in the blog version or in the Postgres database, or in my imdb.sql, where you have the structure of the tables already laid out for you. I described them in the previous video. So we're going to join with movies actors on the foreign key movie ID, and then I'm going to join on actors, so actors A on ma.actor ID equals a.id, the actor's ID. Then I'm going to join directors. I'm going to call this directors table D on m.director ID is d.id. So the movie director ID is the foreign key for the directors table. And then I'm going to run a filter. So I'm going to say where m.title is equal to, and this is where I finally inject my little title argument. And finally, I'm going to group by the tuple of ID, title, year of production, name, and last name with an aggregation function. So I'm going to have an array aggregation, so array ag, on a.name. So I'm going to group all the actor names that are for the same movie as actors. And also d.name, which is the director's name. Cool. So I'm going to say group by. So group by, and I'm going to use m.id, the movie's ID, m.title, m.year of production, d.name, and d.last underscore name. And speaking of the last name, it might be worth concatenating first name and last name of the director with my concatenation operator, a space, and then d.last name. Cool. Now, this is my SQL string, and then I'm going to turn that query into an IO option movie. So I'm going to return query dot query. So I'm going to rename this to statement. Right, so statement.query of type movie, because that's what I care about. And then I'm going to say dot option. And this is going to be a connection IO, so I'm going to use transact on that transaction manager so that I can actually return an effect returning an option movie. Amazing. Cool. Let me run my little method in main. So I'm going to say find movie by title, and I think I have only one movie in my database. It's called Zack Snyder's Justice League. So let me do a little search here. So we have Zack Snyder's Justice League. I'm going to copy that so that I don't misspell this. So let me get back to my code. Find movie by title, and I'm going to use Zack Snyder's Justice League here. And hopefully this query should work and return a single movie aggregating all the actors and everything. Okay, I have a compilation error. Cannot find or construct a read instance for type doobie_demo.movie. Now, you know what to do. We need to create read and write instances for movie. Now, just to speed things up, we have some imports that we can add. So I'm going to import doobie.postgres.everything, and I'm going to import doobie postgres implicits everything. And this should do the trick. So our code compiles, which got us around the error, and we have none, which is a little bit weird, and that is because Zack Snyder has two quotes here because it was written for SQL, not for Scala. Let's run this again with a single quote. Hopefully this time we'll get better results. All right, so we have some movie with its own ID, Zack Snyder's Justice League 2021, and we have a list of all the actor names and Zack Snyder. This is super great. So you can run complex statements with Doobie and return the appropriate types. Now, I want to show you an alternative way of doing the same thing by breaking the query down into its constituent parts. So I'm going to define a find movie by title version 2 with the title as a string, and this will return an IO of option movie. And I'm going to break this down into multiple methods. Let's say find movie by title. And this is going to be SQL quote, and I'm going to use select ID, title, year of production, and director ID. So basically all the plain values from the table, and I'm going to say from movies where title equals, and I'm going to inject my title inside. And then I'm going to say dot query, and I'm going to use a tuple. So this is going to be a unique identifier, string, integer, and integer. So this is going to be a query of string, string, so string, assuming I can spell properly. I got a new keyboard and I'm typing terribly on it. So string, string, int, and int, and then I'm going to use option. All right, so this is going to be an IO returning an option of tuple string string in it. All right, now I'm going to define another method. Let's say find director by ID with the director ID as an int. And I'm going to run a very similar thing. I'm going to say SQL select name and last name from directors, where ID is equal to that particular director ID. Again, I'm going to say dot query with the type string string. Then I'm going to say option again because a director with a particular ID may only occur at most once. Okay. And now another piece, which is find actors by movie ID. So movie ID, which takes a movie ID as a string. And I'm going to run a SQL quote, and I'm going to use a triple quote here. I'm going to select actor name from actors A, join with movies actors. I'm going to call this MA. On the join condition, a.id must be equal to ma.actorID. And the filter is where ma.movieID must be equal to that particular movie ID that I'm interested in. And then I'm going to say dot query of type string because I'm only interested in the actor names. So string, and then I'm going to say to list because there are multiple actors that may play in a particular movie. And finally, I'm going to return my BigQuery. Now, every single bit in my BigQuery in a single string will resemble a flat map in between these pieces that I've written. And multiple chains of flat map involve a for comprehension. So I'm going to run a for comprehension writing the following. I'm going to have a maybe movie. So maybe movie is find movie by title. So find movie by title. And the title is already known from the big method. So find movie by title. Then I'm going to query directors depending on the movie's director ID. So I'm going to have directors in, and I'm going to run a pattern match on this maybe movie depending on whether I find maybe movie or not. So I'm going to have maybe movie match, and in case I get a sum containing some tuple, so movie ID, title, year of production, and director ID, which is what I'm interested in, so director ID, Then I'm going to call my second piece, which is find director by ID on that director ID. And in case I get a none, I'm going to return an option empty. So I'm going to have option empty of type string. And then I will need to return a connection IO, because all of these SQL queries until the run method or until the transact method will return connection IO. So I'm going to have pure of type connection IO. Now my computer is going crazy because these types aren't found and the pure method needs to be imported as an extension method. So I'm going to go up top, and instead of importing Doobie point by point, I'm going to import Doobie everything. And I'm also going to import cats implicits, because the pure method needs to belong to option as an extension method from the applicative type. So now that I've imported cats implicits everything, then all of these methods are known. Cool. All right, so this was directors, actually director, there's only one. Then we have actors, and I'm going to have, again, maybe movie match. And in case I get a sum with movie ID as the first tuple member, I don't care about the rest. Then I'm going to invoke my third piece, which is find actors by movie ID on that movie ID. And in case I get a none, I'm going to return list.empty of type string, and then pure with connection IO as before. All right, amazing. So we have the movie, the director, and all the actors, and I'm going to finally yield. And this is where it's going to get interesting, because maybe movie and director are both options. I'm actually going to call this maybe director 2. And I'm going to run another for comprehension, and I'm going to deconstruct the movie and director immediately. So I'm going to say ID, title, year, and whatever in maybe movie. So notice that I'm already doing the tuple deconstruction for the option, and the first name and last name in the director, or maybe director. I'm going to yield again, and I'm going to have a movie with ID, title, year, actors, which is the list that I'm after, and the director's name, which is an S quote containing first name and last name. Now my laptop is taking off because there are a bunch of magics happening here behind the scenes. So this is simply the query that is before the transact part. So I'm going to say query.transact on that transaction manager, and this will return my final effect, an IO of option movie. All right, so this is how you can split a large query into pieces. Now, this may or may not be what you want, because this obviously involves much more code. But if you are generating a giant query programmatically, it might be worth splitting it into pieces like this and then doing pattern matches or pure functional programming in terms of for comprehensions and that sort of stuff, if that is your taste. So we have alternatives. Cool. Let's try find movie by title version 2. So all I need to do in theory is just add the version 2 suffix and then let everything do its course. And I have a giant stack trace, so operator does not exist, UUID. Now I forgot that in the table definition, the movie's title was a UUID. So if I go to my IMDb, if we look at the movies table, it says that the type of ID is a unique identifier. So we need to use that instead of string. So I'm going to type my pieces with UUID instead of string. So this piece is UUID. So I'm going to use that from Java. So import Java util UUID, and the compiler will yell in my face in a bunch of places. And that is because here in the movie ID, find actors by movie ID, I'm going to say movie ID.toString. And finally, pass the movie's identifier. Instead of UUID, I'm going to say ID.toString to turn that back into the string because that's what the Scala case class requires. Let's compile this again. Hopefully it runs smoothly this time. But I think the error is a little bit more silly than I make it to be, because the movie ID, when injected into an interpolated string, I'm not really sure how that looks like. So I would rather turn this movie ID into UUID instead of a string and cut down the toString conversion there and try to run this again. Maybe, just maybe, it'll work correctly because of the formatting. All right, finally, so we have our little movie, Zack Snyder's Justice League, as we did earlier in the big SQL query. All right, folks, thank you so much for following along in this video. This was your part 2 of how to run pure functional programming while interacting with the database with Scala and Doobie. Check out the written form in the blog with the link in the description for more information about how to do all kinds of good stuff with Doobie, more than I could show here on camera, including a tagless application with Doobie and higher kind of types. So go ahead and check that out. Check me out on Twitter and LinkedIn for fresh updates on upcoming material, and check out my website at rockthejvm.com. We have hundreds of hours now on Scala, functional programming, Akka, Apache Spark, Cats Effect, and all of that kind of good stuff. I have lots of material for you, waiting for you at Rock the JVM. I'm Daniel, signing off and waiting for you in the next video.